Hey, what's going on, guys? Welcome to another math tutorial video. And in this video, we're going to be looking at how to find the zeros of a function, and then we're going to sketch the graph based on those zeros. So we're going to look at this problem that we have in front. G of x is equal to negative 4x to the fourth power plus 8x to the third plus 60x to the second. Now, when we're talking about finding the zeros, essentially what we're trying to figure out is where does the graph of this function cross the x-axis on a coordinate plane? And we've learned so far that what we need to do first is we need to factor our function or our polynomial as much as we can so that we can then use the zero product property to find those solutions, to find those zeros, those x-intercepts, those roots. All those words mean essentially the same thing. So we're gonna jump into this problem here. And what I want you guys to notice here is that we have g of x in front of the function or the equation. And what this means is that's just the name of the function. And since we're trying to find the zeros, what I'm going to do is I'm going to replace the g of x with the value of 0, because we're saying that when the y coordinate is equal to 0, what is the x coordinate going to be? So I'm going to replace g of x with 0, replace it with 0, and then I'm going to rewrite my function as negative 4x to the fourth. So I'm writing it again. Okay, there we go. Now, most students are not used to seeing the 0 on the left side. So just for the purpose of instruction, I'm going to rewrite my function once again, but I'm just going to put the 0 on the right. Okay, so just so that I don't lose anyone here. So I'm going to rewrite this, and I'm just going to write negative 4x to the fourth power plus 8x to the third plus 60x squared is equal to 0. I literally just moved the 0 from the left to the right. Okay, now we get to this point, and what we want to figure out is, okay, is there a GCF, or a greatest common factor, that I can factor out from my polynomial? And what I want you guys to pay close attention to is in front of our degree or our highest power, which is 4, we have a negative symbol. And when you're factoring, you want to try to see if you can get rid of that negative symbol in front of your leading coefficient of your highest degree, because it's going to make your life much easier as you progress through the problem. So I'm going to factor that negative, and I also know that I can factor a 4 with all the terms, and I can also factor an x squared. So that's going to be my GCF for this problem. And I'm going to go ahead and rewrite my problem with the GCF factored out. So I'm going to rewrite my problem here, and I'm going to write negative 4x to the second power times x to the second power, which is what I'm going to be left with if I factor a negative 4x squared from the first term. The second term, if I factor a negative 4x, I'm going to be left with negative 2x. And then finally, I'm going to be left with negative 15. And I'm going to close my parentheses. I got to make sure I bring the 0 with me, because again, we're solving for the zeros or x-intercepts. All right. Now that we're at this point, what we want to try to do is, okay, inside of the parentheses, I have a trinomial, or a polynomial with 3 terms, and inside the highest power is 2. So I can actually try to see if I can use the x method or the diamond method for this portion. So I'm going to do that on the left side here. Let me just zoom out a little bit. I'm going to do that on the left side. Okay. And I want to try to figure out if it is possible to factor what's inside of my parentheses using the X method. So I know that on top, I'm going to put the number 15. And then on the bottom, I'm going to put the number -2. That's my B. And -15, 8 times C of our quadratic function in standard form. Okay, so I want to ask myself, what two numbers do I multiply together to get -15? And when I add them, I'm going to get -2. And just in the interest of keeping the video short, I know that my two factors are going to be -5 and +3. So it's always good to do the test. -5 times +3 will give me -15, and -5 plus 3 will yield me -2. So I have my two factors. I can now rewrite what's inside my parentheses in factored form. And just one quick reminder, as you're progressing through this problem, you don't forget your GCFs. So I'm going to bring down my -4x to the second. That's my original GCF. And then I'm going to rewrite what's inside my parentheses as x minus 5 times x plus 3. And I'm going to make all of this equal to 0. All right, so we've gotten to this point. We can't factor any further. So what we do then is we use the zero product property to make each part equal to 0. And let me show you what I mean. I'm going to drop the colors since now I'm just trying to solve for it. So I'm going to write -4x to the second power is equal to 0. I'm going to put x minus 5 is equal to 0. And I'm going to put x plus 3 is equal to 0. Alrighty. So we've gone through half of the battle. The next part here is to try to then solve for each part of our factored polynomial and get our zeros or our solutions. So on the first part, I have -4x to the second is equal to 0. I want to isolate my variable to get my solution. So what I'm going to do is I'm going to divide both sides by -4. I'm going to divide both sides by -4. And when I do that, that is going to give me x squared is equal to 0. I'm going to do this. I'm going to also isolate the variable on my second part here. So -5, the inverse of -5 is +5. So I'm going to add 5 both sides. That's going to leave me with x is equal to 5. So I got my I got one solution. We're going to go on to the next one. Isolate my variable. I'm going to subtract 3 on both sides so that my x is by itself. And I'm going to be left with x is equal to -3. So we've got two solutions so far. I need to clean this up a little bit further. I have x squared is equal to 0. Now, this is just getting really technical, but I want to show that step. I have x squared, and I want to get rid of that power of 2, or that square. So the inverse of a power is taking its root. So if I want to get this power of 2 to the other side, I'm going to then take the square root on both sides. And that's going to leave me with x is equal to 0. And that's it for that one. So I'm going to bring these guys down. X is equal to 5. And then x is equal to -3. Alrighty. Now, one last thing that we want to do when we're writing our solutions, at least I like to put them in order from from how you would see them on a coordinate plane. So if we're talking about the x-axis, we're going from negative to positive. So I'm going to rewrite this. I'm going to rewrite my -3 as my first solution. X is equal to -3. I'm going to then write my second solution, which is going to be x is equal to 0. And then I'm going to write my third solution, which is going to be x is equal to 5. All right, so now that we have our 3 solutions, we're going to go ahead and look at the graph and compare and confirm that these in fact are our solutions. And then I'm going to show you what the graph looks like for this function. All right, so here we are. I went and typed my function onto the Desmos calculator, and then I recalibrated or scaled my coordinate plane so that you can kind of see what the graph looks like more or less. So we see here that we have 3 solutions. Clearly, there's 1, there's 2, and then there are 3. So what I'm going to do is I'm going to take a snapshot of the graph, and then we're going to confirm whether we got the solutions accurately. All right, so we're back, guys. We have our graph on the right side here that I captured from Desmos. This was our original function before we factored it. And as you guys can see, there are 3 solutions, or zeros, whatever you want to call them, and they check out. Our first solution is -3, -3. Second solution is 0, 0, and then our third solution is 5. And don't get thrown off by how the solutions are presented. They're given in a coordinate set. But if you guys remember, when we were working in the beginning of our problem, we made our function equal to 0 because we wanted to figure out when our y is equal to 0, meaning that there's no movement on the y axis, what are going to be our solutions, or our x coordinates. So I hope that makes sense. All right, guys. So I hope that you found this video tutorial helpful on how to find the zeros of a function and then sketch the graph based on those zeros. Stay tuned for more videos to come.